This is 1.6 solving equations. So when we start solving equations, we're obviously trying to find out what x is. And so let's start with this first one. These are higher exponent, higher power equations. So we're going to take the 25x to the fourth to one side. You almost always want to set them equal to 0. And then we're going to factor out the GCF. And then don't stop there. Notice it can factor more. A perfect binomial. And then what we're going to do is set each of those equal to 0. So x to the fourth equals 0, x plus 5 equals 0, and then x minus 5 equals 0. So this leads to x equals 5. This leads to x equals negative 5. And this leads to x equals 0. And you do need to check each one of these values to make sure that they actually do work. I just want to emphasize that. All right, so let's go to the next one. And here we have 4 terms. And I've emphasized several times, whenever you have 4 terms, think of grouping, live long and prosper. That's what I have normally said to you guys. So here, if you look at the first 2 terms, what's common is x squared. And factor that out, and you're left with x plus 3. Look at the next 2 terms. You have negative 4, and you have x plus 3. And these guys will always match. So you have x squared minus 4, and then the x plus 3. And notice this factors x plus 2, x minus 2. And when you set them equal to 0, you're going to get plus or minus 2 and negative 3. Now, just, you should always plug them in to check them, but as far as checking purposes, if you can also use your calculator. Remember what these answers mean. These answers mean that's where they're zeros, they're x-intercepts. Whenever you're finding an equation, you're finding out basically where it will make it the x-intercept. And that's why we're setting it equal to 0. That's your y part of it, of the point. And so, you can do it on each one of these. If you graph them, you can literally just pull up on the graphing calculator, just pull it up. We're going to plug, let's check this purple one. So I plug this in, I push graph, and notice it does cross at negative 2, negative 3, and also positive 2. So as for checking purposes on your homework, that will tell you if those actually do work for your zeros. All right, so let's go on to the next one. Here we're trying to solve this. And keep in mind that this one right here is factored form, x plus 3, x minus 3. So to get rid of, because it's an equation, we're not like adding or subtracting all these fractions, but to get rid of the equation, the denominators, we're going to multiply everything by the common denominator. So we're going to just multiply everything by x plus 3, x minus 3, and x. That's what we're multiplying everything. The left side, what you do to one side, you have to do to the other. All right, so when you use the distributive property, so you're going to take all of that and multiply by here. The x's will cross out, and so you're going to have 3, and then x plus 3, x minus 3. And then when you use the distributive property here, the x minus 3's cross out, so you have 2x, and then x plus 3. Again, the denominators are crossing out. Here, the denominators cross out, and you have negative 12x. All right, so we're going to use the distributive property here, multiply those two together, and multiply it by 3. So here you have x squared minus 9, but we're going to multiply it by 3. So that's going to give us 3x squared minus 27. And here we're distributing a negative 2x. So negative 2x squared minus 6x equals negative 12x. And then, of course, we're going to set it equal to 0 by like terms. So we have x squared, and then we have, so when we combine like terms, we're going to end up with x squared plus 6x minus 27. This does factor, which means x is negative 9, and x is 3. And again, I want to emphasize, make sure you check your answers. Now, something I almost said at the very beginning, but I wanted to emphasize this at the end. Notice at the very beginning what x cannot equal. Okay, x cannot equal 3. Cannot equal 3. It also can't equal 0, and it also can't equal 9. But we didn't get any of those. We did get 3. So if you notice, x cannot equal 3. So that is not a possibility. So the only solution is -9 for that problem. All right, let's solve this. To get rid of a square root, you square both sides. So we're literally going to square both sides, and we have 8x minus 1 equals 9. And we're going to add 1 to both sides. Divide by 8, and reduce. We're going to get 5/4. Now, when you check that, again, you're checking to see if it equals 3. So if you take 8 times 5/4 minus 1, that goes to 10 minus 1, and the square root of 9 is 3. So 3 does equal 3. It does work out. But always check your solution to make sure it does work. All right, so let's look at this last problem. Again, what we want to do is to get rid of that square root. And to get rid of a square root, we're going to end up squaring both sides. So to do the best way to do this is to isolate the square root. So we're going to literally take the 1 over to the other side. Now we're going to square both sides. So we're literally going to square this side, and we're going to square this side. So this side, the square root and the square cancel. Here, you're literally going to FOIL this. X minus 1, x minus 1, and you're going to FOIL it. So that's going to give us x squared minus 2x plus 1. And we're going to bring everything over to one side. It's easier in most cases to make the x squared positive, so I'm going to take it to the right. We're going to factor out an x. So we get x equals 0, and we get x equals 4. And again, make sure you check your answers to make sure that they work. So if I plug 0 back in at the very beginning, so 2 times 0 plus 1. Notice I substituted in I substituted in 0 there and there, right where those x's are. And so here I'm going to get the square root of 1. And the square root of 1 plus 1 is still 2. 2 equals 0. No, it doesn't. So we know 0 does not work. If we go back and do 4, we're going to see the same thing. 4 times 2 is 8, or not the same thing. We're going to plug it in and see if it does work or not. So plug 4 in. 4 times 2, so I'm plugging it in right here. That's 8. 8 plus 1 is 9, and the square root of 9 is 3, and then 3 plus 1 is 4, and that does equal 4. So this one does work, so this is the only solution to that equation. One last problem, I forgot about this last page. If we went and solve this equation, and notice this one is x to the 4th. And so a lot of us might look at it like, well, wait a minute, if it was, I think that's supposed to be that right there. Yes, it is. All right, so if we're solving this equation, a lot of us are like, well, I don't know how to factor something like that. And if this was a problem very similar, let me just do something like this. If it was something very similar, if we try to factor x to the 4th, if we try to factor this does factor. So I mean, you should always try to factor something and then see if it works. And then here you said this equals 0 and said this equals 0 and solve. So you could solve like that, but this one doesn't actually factor nicely. So what we're going to do is we're going to end up solving this using a little substitution method. What we're going to do is literally set, let's just say W, for instance, and you could use any letter you want, but I'm just going to use W, and we're going to let W equal x squared. we're just going to make a substitution, w equals x squared, which means this is actually w squared minus 8w plus 8. So again, I just made a simple substitution, w to the first power equals x squared. So I just made that substitution. And then I'm going to, again, it still can't factor, but I can use the quadratic formula. So if I started using the quadratic formula, so x equals negative b plus or minus the square root of b squared. So we have negative 8 squared minus 4 times a times c divided by 2a. And once we simplify that, we're going to end up getting, I use x, that's a w now because I made that substitution. All right, so we're going to end up getting 4 plus or minus 2 square root of 2. And that's what w is. But remember, w, now let's substitute it back in. W is actually x squared. And then, of course, we're trying to solve for x. So then we're going to square root both sides. So here's where you got to pay attention. Remember, whenever you square root both sides, we got plus or minus. So we're going to have literally this right here, plus or minus 4. So notice what this is. We have literally 4 different answers that we have to consider here, which we kind of knew that because of the exponent. So we knew that there was 4 possible scenarios. So we have a positive square root of 4 plus 2 square root of 2. We have a negative square root of 4 plus 2 square root of 2. We have a positive 4 minus 2 square root of 2. And we have a minus 4 and then minus 2 square root of 2. And so, and then those are all 4 different answers. And then what we're going to do is do decimal approximations to get to our solution. And so we have our 4 decimal approximations. And again, you can check them as well. I just plugged it in on the calculator, just plug that function in, push graph, and you can see that it crosses at 2.61, negative 2.61, 1.08, and negative 1.08. To see all 4 solutions are there. So that's how you solve equations with higher exponents.